Alrighty, and here's an example of what I consider easy direct variation problem. Alright, so the acceleration of an object varies directly, and whenever it says varies directly, that's your indication that it's a direct variation problem, as the force acting on it. So underline your variables first thing. If a force of 240 newtons caused an acceleration of 150 meters per second squared, what force will cause an acceleration of 100 meters per second squared? Alright, so after going through the problem one time, you know it's a direct variation problem, but when it says varies directly in the problem. So you'd bring that down, bring the equation down, y equals kx, sorry. That's your direct variation equation. And a way to know like what x and what y is y is always said first. Just like in the sample problem right here. It says if y varies directly as x. Just think about it like that. Like y is always said first. It's like almost saying like y is dependent on x. So knowing that, a equals acceleration, or it can be y, and F equals force, or x. And you can rewrite that equation as A equals KF. Okay, so it says the A is 150 meters per second squared, whenever the F is 240 newtons. Alright, so you plug those in, because remember the first thing you want to do is solve for your constant, because you want to be able to solve for the second part. So you do 150 equals K, that's a bad K, and 240. So divide that, just like in the sample problem. Equals K, then you would get, for that, you'd get 0.625 equals K. That's your constant. And remember, you're going to use your constant to solve the second part of the problem. So the second part of the problem is, what force will cause an acceleration of 100 meters per second squared? So, knowing that the acceleration is 100 and the constant is 0.625, you can have another equation, which 100 equals a constant, 0.625, and then F, because that's what you're trying to find. What is F? So you basically do the same exact thing you did over here, because whenever you're solving for a variable, you want to leave the variable isolated on one side, the variable you're solving for. So right over there. So 100 divided by 0.625 equals F, and then putting that in the calculator, you would get 160 equals F. And F is in newtons because it's force. So when the acceleration is 100 meters per second squared, the force would be 60 newtons. Now I'm going to show you a medium problem.